Gay-Lussac's law. So the problem that I want to use as a representative example is the one that just talks about generic gas, right? So I'll read off the problem and then we'll talk about what's on the board. So it says a gas has a pressure of 2 atmospheres. So there's my initial pressure. And at 18 degrees Celsius. Well, I've gone ahead and immediately added my 273 to convert Celsius to Kelvin. The exact conversion is 273.15. But if I look here, I'm already in 3 sig fig. So when I use my 273, that also has 2 sig fig. So I don't necessarily need the 0.15. But if you'd like, you can include it. So there's my 18 degrees Celsius converted to Kelvin. And then it says, what is the new pressure? So what is P2? When the temperature has been increased to 62 degrees Celsius, which when added to 273 is 335 Kelvin, right? So what we're starting to notice is that temperature is the only unit using the gas laws that has to be Kelvin. We saw in a couple of examples we've already used millimeters mercury. That's fine. My answer if I'm solving for pressure just happens to be in millimeters mercury. Here it's atmosphere. Atmosphere here, that means P2 will also have the same units of atmosphere, right? Temperature is the only one we need to make sure we're paying attention to. So for Gay-Lussac's law, right, we recognize why we're using Gay-Lussac's law because if we look here, I'm only giving pressures and temperatures, but it specifically tells me that volume and the number of moles are constant. So those are my conditions. So there's my Gay-Lussac's law. I'm going to keep going through because I think it's much more intuitive to use just the letters first and then dump the numbers in. But again, if you're comfortable or uncomfortable with that, right, it's more than okay to just put the numbers in first and then actually solve like that. But here, I can see I'm solving for P2. So let me rearrange this to solve for P2. So if I multiply both sides by T2 again, what I'll see is I'll end up with P1 over T1 times T2. And now I'm left solving for P2. So now I can put my numbers in. P1 was the 2 atmospheres, so 2.00 atm. My T2, my second temperature is 335 Kelvin. And then my initial temperature, right, was at 18 degrees Celsius, which I've already converted to Kelvin. That's my 291 Kelvin. Units of Kelvin cancel. I'm left with units of atmosphere, exactly where I want to be because I'm solving for a pressure. What I should get then is 2.3 ATM. Actually, let me check. Actually, my calculations might be slightly less sig fig. Oh wait, no, my bad. I read the problem wrong. There was actually only 2 significant figures with the pressure, so having an answer of 2.3 actually does make sense. Sorry, there's my little fault on that. But that's Gay-Lussac's law.